Today we're learning about angle relationships. Special angle pairs can help you identify geometric relationships. You can use these angle pairs to find angle measures. The first type we're looking at is called adjacent angles. And adjacent angles are two coplanar angles with a common side, a common vertex, and no common interior points. If we look at the example, we can see from example here, this one, with angles 1 and 2, this is our common side. So both of these angles, I'm going to trace over one of them with blue and the other one with pink. These angles share this side. They also have a common vertex. Adjacent angles have to meet this criteria. So they have to have a common side, they have to have a common vertex. If you look at angle 3 and angle 4, angle 3 is this angle 4 is here. Their common vertex is located here, and they share a common side right there. If I drew you another example of adjacent angles, we could have something like this here. With our common side being in the middle. Next, we're looking at vertical angles. So vertical angles are two non-adjacent angles formed by intersecting lines. Vertical angles are congruent and equal. If we look at our example, we have two intersecting lines. They intersect and form a common vertex for all of the angles. So across from each other, these angles are going to be congruent. So angle 1 and angle 3 are congruent. Also, angle 4 and angle 2 are congruent. So if I write this out, I know that angle 1 is congruent to angle 3, and I know that angle 2 is congruent to angle 4. Next, we have complementary angles. Complementary angles are two angles whose measures have a sum of 90 degrees. Each angle is called the complement of the other. These angles do not have to be adjacent. They can be two separate angles. Looking at our examples drawn out, these two angles form complementary angles because 47 plus 43 is equal to 90. But also, these angles here are complementary. These are both complementary and adjacent. They are adjacent because they share a common side. Of course, complementary angles do not have to be adjacent, but they can be. Supplementary angles follow the same pattern as complementary, except supplementary are two angles whose measures have a sum of 180 degrees. In this case, each angle is called the supplement of the other. Looking at our model, these here are supplementary but not adjacent because they do not share a common side or a common vertex, but 137 plus 43 does add to 180. This example here is adjacent and supplementary, so they do share a common side and a common vertex. Here's your common side, and of course the common vertex would be here. And the last relationship that we're going over is a linear pair. So a linear pair is a pair of adjacent angles whose non-common sides are opposite rays. The angles of a linear pair form a straight angle. So a linear pair has to fit two things. It has to be adjacent, and it has to be supplementary. Those two things have to be true. Looking at our model here, you can see that we have a straight angle. We also have a common side. So this common side, that proves that we have adjacent angles. We have a common vertex. Whatever the measure of angle 1 is, plus the measure of angle 2, is going to equal 180 degrees. So we're going to use all of these relationships to help us solve for missing angle measures, or to prove congruent angles. Looking at example 1, here we're just using the diagram to answer some questions about it. So number 1 is going to use this diagram, and the first question says to name a right angle. So be on the lookout for your right angle indicators, and in this case I see angle 3 as a right angle, but I also know that angle 3 and angle 6 are vertical angles, so angle 6 is also a right angle. Part B says to name a pair of complementary angles. So complementary angles add to 90 degrees. So sum to 90 degrees. There's multiple pairs. I'm going to list them, but then I'm just going to write out one of them. So I'll verbally list all of them, and one of them I'll write out. So angle 1 and angle 2 have to add up to 90 degrees, because if this is a straight angle, and we know that this here is 90 degrees, then we know this part here also has to be 90 degrees. So angle 1 and angle 2 is a pair of complementary angles. You could also say that 4 and 5 are complementary. Part C says to name a pair of adjacent angles, and recall that adjacent means common side and common vertex. Any two angles that are next to each other are going to be adjacent. So we could say angle 1 and angle 2. We could say angle 2 and angle 3. We could say angle 3 and angle 4, 4 and 5, 5 and 6, or we could say angle 6 and angle 1. So just pick one pair of adjacent angles. I'm going to say angle 5 and angle 6. But in this case, you have so many more options. So just make sure you fit the criteria of the angle pair. Part D says to name a pair of supplementary angles. Supplementary angles sum to 180 degrees. So we're looking for two angles that are going to add up to 180 degrees, and it can only be two angles. So two angles at most. A pair means two. So the only two angles here that are going to add up to 180 degrees would be angle 3 with its right angle, and also angle 6. The other angles are too small, and you would have to use more than two. So we are only looking at angle 3 and angle 6 as an answer for part D. Number 2 uses a different diagram. We're looking at this one here. We need to name two acute vertical angles. Acute means less than 90. And vertical angles are angles that are opposite each other by two intersecting lines. So you can think of vertical angles as looking like an X. That is not a mathematical definition, but if you trace over vertical angles, such as these here, those are lines that intersect and form a common vertex. It also appears to look like an X. So anything like that is going to create vertical angles. Now that I just highlighted the two vertical angles, I'm looking for the acute pair, and the acute pair would be the pair that's less than 90 degrees. So I could say angle LCQ and angle XCB. So not only are these angles vertical, but they are also congruent. So I could write another statement that says LCQ is congruent to angle XCB. Part B says to name two obtuse adjacent angles. So obtuse means greater than 90. And adjacent means they share a common side and a common vertex. So we're looking for two obtuse adjacent angles. I'm going to label this as, or my answer, so a possibility, angle MCB, and also angle BCQ. Both of those are larger than 180. I'm sorry, larger than 90, but share a common side, and they also share a common vertex. So that was angle MCB and angle QCB. Next, we're going to use our angle pairs, so the relationship between two angles, in order to find the value of the variable. We also are going to identify what we're using in order to solve. Number 1, I hope everyone recognizes right away, it has the appearance of an X, and we have a common vertex. If this is the case, you have vertical angles that are congruent to each other. If you have vertical angles, then you know that they are equal to one another, congruent or equal to one another. So I can set up an equation of 120 is equal to 2x minus 10. If I am solving for x, I'm going to add 10 to both sides, giving me 130 is equal to 2x. Divide both sides by 2, and x is equal to 65. This is not the only way that you could have solved for x. You could have also looked at the diagram and you could have seen a linear pair. So for example, if I erase what I have on here, a linear pair is formed by a straight angle. If this angle is 120, then you can easily find this angle here. It would be the remainder to get you back to 180, which would be 60 degrees. And you could just keep working your way around. Now we know that this is also a linear pair. We know that 60 plus whatever this is going to equal 180. So we could solve for x that way. That's a lot more work than what I just did for vertical angles, but it is another way to solve. Number 2, For number 2, we're solving for two variables. I see that I have the variable y, but I also have a variable x. So I'm going to start by recognizing my vertical angles. I recognize that I have these two angles that are congruent or equal to one another. If I use those angles, I can set them equal to themselves, or equal to each other. So 8y minus 102 is equal to 2y plus 6. I'll subtract 2y from both sides. 6y minus 102 is equal to 6. Add 102 to both sides. 6y equals 108. And y is equal to 18. Okay, I'm not done with my diagram, or I'm not done solving at this point because I still have to solve for x. So now I'm going to highlight that this angle here and this angle, so these two angles are a linear pair. And a linear pair sums to 180. We have 3x plus 2y plus 6 is equal to 180. But this angle, we can find what this angle is. 2y plus 6. If we substitute our y value of 18 into this equation, we have 2 times 18 plus 6. And 2 times 18 is 36, plus 6 is equal to 42. So this angle is 42 degrees. So I know that 42 degrees plus 3x is equal to 180. If I subtract 42 from both sides, I have 3x is equal to 138. And when I divide both sides by 3, I know that x is equal to 46. And that is my final answer for x and y. Looks like the diagram is a little bit misleading as far as the angle measures go. Every now and then that happens, but what we did for solving is still accurate. So we used vertical angles to find the angles opposite one another, and we used a linear pair to find the angles that are next to one another. So angles that are next to each other and form a straight angle are called a linear pair, and they sum to 180 degrees. So please try the on your own section on the next page by yourself. Press pause on the video, and then you can come back to the video and you'll see that I did the on your own section, so you can check your answers.